Happy learning. So today we are going to discuss about van pumps. There are three types of pump: unbalanced van pump, balanced van pump, and pressure compensated variable displacement pump. So let us discuss unbalanced van pump. Now look at the drawing. Unbalanced van pump. See that the inlet portion and outlet port. The left side is the inlet port and the right side is the outlet port. And there is the cam ring. This is the cam ring, and that is also called pumping chamber. And the rotor, is located eccentrically with respect to the pump. And the inside the rotor, the slots will be there radial in radial direction. The slots will be there, and inside the slot, the vans will be fitted with the help of the spring. The fitted, and normally this vans are inside the slot, and this rotor is connected to the motor. And whenever the motor is switched on, the rotor will be started to rotate, and along with this rotor, the vans also will be started to rotate. Now normally these vans are inside the slot, and because of the centrifugal force around the periphery of the rotor, the vans will be coming out from the slot, and it will occupy the pumping chamber, that is the cam ring. Now along this rotor, the vans also will be started to rotate. Now see this left side. The left side portion, if we look at the left side portion, the space between the vans, it is gradually increasing. So the volume is gradually increasing. That is the vacuum will be created, suction will be created, and negative pressure will be created. And because of this pressure difference, the oil will be getting into the pump. Now the oil will be carried away by the vans. Because of the movement of the vans, oil will be carried away. And when it is coming to the right side portion, the volume is getting decreased. So gradually it is getting decreased, and the pressure will be increasing. So the high pressure, the pressurized oil, once the pressurized oil will be getting into the outlet portion, and it is getting into the fluid power system. Now this is based on this pumping action, the suction and the discharge, and the low side and the high side. And this pumping action is carried out because of the eccentricity of the rotor, because of the position of the rotor. Since the rotor is eccentrically located, and we can able to generate the low side and the high side. We can able to generate suction, and the oil can be get into the pump, and we can generate the high pressure, and the high pressurized oil can be discharged into the system, fluid power system. So in unbalanced van pump, the one side is the low side and the other side is the higher side. So the pump is subjected to the pressure on one side, and the suction pressure, the low side on the other side. And because of this pressure difference, the motor bearings are subjected to the stress and strain. And to avoid this, we go for balanced van pump. Now look at the balanced van pump. The inlet port, there are two inlet port and two outlet port, and the inlet and outlet port will be placed alternatively. Now look at this. Now this is the inlet port. And see this, and here also the rotor is fitted eccentrically with respect to the pump, and because of the eccentricity, the suction and the low side and the high side can be generated. Now look at this. When it is moving to the opposite in the counterclockwise direction, the vans, they're similar to the unbalanced van pump, and suction and the volume is getting increased. And since the volume is increasing in between the vans, and suction will be created, negative pressure will be created, and oil will be getting into the system, pump. And after that, the volume is decreasing, and the pressure of the oil is getting increased, and oil will be getting to the outlet port. So now this action will be carried out continuously. Again the volume is increasing, and suction will be, negative pressure will be created, suction will be created, and oil will be getting to the system. And again, because of the position of this, the rotor and the vans, the space between the vans will be increasing, suction will be created, and space between the vans will be decreasing, and the high pressure will be generated, and the high pressure oil will be getting to the outlet portion. So in this way, the low side and high side are getting balanced, and so that the extra stress and strain on motor bearings will be avoided. This is the balanced van pump. Now this is pressure compensated variable displacement pump. Now it is similar to the unbalanced van pump, and there is a cam ring, and there is a pumping chamber, and that is a pumping chamber, and the rotor. The rotor is eccentrically located with respect to the pump axis, and inside the rotor there will be the slot radially, and the vans will be fitted inside the slot, and it is spring fitted, and whenever the rotor is getting started to rotate, and the vans will be coming out from the rotor because of the centrifugal force, and this is looking like the unbalanced van pump. Whereas here the outlet pressure should be maintained constantly. To maintain the constant and continuous pressure outlet, we go for pressure compensated variable displacement pump. Now look at this. In the left side part, the compensated spring is there, and the outlet port the right side port, and the compensator piston is there, and the piston pressure, the outlet pressure will be get into the piston, compensator piston, and so that the one side of the cam ring and the outlet pressure, system pressure, the outlet pressure from the pump, that is system pressure will be acting. The other side is the compensator spring. Now both the pressure will be maintained constantly, and the same pressure will be maintained. Spring pressure as well as the outlet pressure will be the same. Now see this, if the spring is mounted, the spring is giving pressure on cam ring, and here the piston, compensator piston, is giving pressure on cam ring. Now because of this, the cam ring will be moving left to right or right to left. Now look at this. The maximum displacement, the maximum pressure will be happening when the eccentricity is more. Now eccentricity is the distance between the center of the rotor and center of the pump, center of the cam ring. If the distance is more, the eccentricity is more, the more pressure will be created. Now suppose let us assume that the pressure is increasing, or pressure is increasing than the required limit. So at that time, the outlet pressure will sense the increase in pressure, and so that it will push the cam ring, and since the cam ring is moving from left to right, and the cam ring will be moving left to right, and the eccentricity will be reduced. That is, the distance between the center of the rotor and center of the pump will be reduced. Since the eccentricity is reduced, then automatically the pressure also, the displacement also will be reduced, and pressure also will be reduced, and so that the outlet pressure is getting maintained. Similarly, if the pressure is less, the outlet pressure will be less, and this pressure is lesser than the compensator spring pressure. Since the spring pressure is more, and it will push the cam ring, and so that the cam ring will be the cam ring will be moving towards the left side, and so that the eccentricity will be increasing. The eccentricity will be the distance between the center of the rotor and the cam ring will be increasing, and so that the more displacement will be there, more pressure will be generated. And this is how the variable displacement pump is working.